In this session, we're going to talk about autoscaling, when you should or should not use it, and how it works in Nerdio for Azure. Autoscaling is a foundational element of learning how to build a profitable cloud practice in Microsoft Azure, as the primary cost of Azure is that of compute, which with autoscaling reduces your compute spend. Keep in mind that the way to completely shut down the compute meter in Azure is through reserved instances, and we'll spend some time reviewing this topic as well. Enjoy the session.
All right, today I want to talk about autoscaling and review in a bit of detail how it works on the back end, talk about the scenarios when you should or should not use it, and then look at the specific instances of where autoscaling comes in and what it does. So with that, let's first of all understand what autoscale is. So autoscale is a function that reduces the cost of compute of running VMs in Azure. So if you think about the cost of an Azure-based solution, you're going to have things like the cost of the VMs themselves, which we call, compute costs. You're going to have costs of the storage associated with those VMs, or maybe some other storage. You may have costs for bandwidth, IP addresses, VPN gateways, lots of little pieces that come into play when you are deploying an Azure-based environment. The biggest cost component, probably 50% or more in a typical scenario, is going to be the cost of compute. So when we're talking about optimizing costs, it makes sense to start with the thing that's the biggest slice of the pie. In our case, it is the compute costs. So autoscaling basically increases and reduces compute to try to match it as closely as it can to the need for that compute capacity, as opposed to keeping things running 24/7 and always paying for that compute capacity in a sort of a level way throughout the day and week. The alternative method to saving money with compute capacity is by using reservations. Reservations and reserved instances, sort of, it's an interchangeable same thing. So reservation equals reserved instance, and the reservation is a way to prepay for compute capacity, where you're going to be paying for it upfront in advance, and you're going to get a significant discount on a reservation. And as a result of that discount, you've now been assigned a certain amount of capacity you can use at no additional cost, meaning you've already paid for it upfront. What that leads to is, if you have a reservation, your goal is to utilize that reservation as much as you possibly can, right? If you're utilizing it 100% of the time, then you're actually realizing all the savings that reservation and paying for it up front has provided you. If you're utilizing it only a fraction of the time, then you're really not taking advantage of what you've paid for. So when you're using reservation, you want to run the VMs that the reservation covers as close to 100% of the time as you can, as long as you need them to run like that, which means that autoscaling those VMs that are reserved makes no sense from a cost perspective, right? It makes no sense to take $1,000 a month VM that you've already paid for and shut it down at night in order to save money, because you are not going to save money. So it's important to understand that autoscale is an alternative to reservations, and you need to figure out on a case-by-case basis which is the more cost-efficient way of getting the most amount of savings. So let's look at that practically. So if we look at the cost of VMs on the Azure price list, so there's basically all these different groups of VMs, and what you'll see is that there is this pay-as-you-go price, kind of, let's call it, that's the base price. And then you have 1-year reservation and a 3-year reservation, which are the only two options. And it gives you an estimate of what that savings is. So with a 1-year reservation, you get a discount of 35%. Now, it breaks it down to a monthly cost right here, but that's not really true. You're not really paying for it monthly. You're paying for it all up front. It's just if you divide it over 12 months, you will get roughly this amount per month. But that is not how you're paying for it. It's all paid up front. And if you go to a 3-year reservation, you're getting something in that range. And this varies by VM family. Like, for example, some of the older VM families don't even have reservations because they don't want people to pre-purchase capacity in VM families that I think eventually they're going to be retiring. And also some of the highly in-demand VMs don't have reservation options because they want, if they don't have enough capacity for everyone, they would much rather everyone pay a higher price, and the people who can't pay the higher price, basically, there's not enough capacity for them anyway. So if you kind of scroll through this page, you see the different series have different percentage savings. So you have, again, here's the D series version 3. It's about 23% and 34% versus a B series, which was what? 35 or 35 and 50, 31 and 50, etc. Right? And some of these even get into 54. So what does this mean? So that means that if I can save more with Autoscale than 54%, then Autoscale is a better way for me to optimize my costs rather than buying a reservation. Okay, so what does that mean? That means that if there's, let's say, 740 hours in a month or so, so if you're going to be running a VM half of that time or less, then the Autoscale is going to be more cost effective. And not only is it going to be more cost effective, it's going to give you more flexibility because maybe some months you're going to even be able to save more than 50%, right? Maybe you can only run it 10% of the time because people are on vacation or whatever the case may be. It gives you more flexibility because you're not committing to a 3-year or a 1-year term. Whereas with a reservation, you have a commitment and you get a fixed discount for the next 3 years and you kind of know exactly what it is. The advantage of a reservation, right, outside of the actual dollar amount and the discount is the fact that with a reservation, you're not really messing with the VM. So you don't have to shut it down to resize it. You don't have to destroy it and recreate it. So, the edge cases of users who are logged into VMs that are auto-scaled, right? There are going to be users who are, despite the fact that they may not need to be working after a certain time or on the weekend, there may be users there. And if Autoscale kicks in, it will need to knock them out to log them off in order to perform the operation. With a reserved machine, you don't have to worry about it. You just always keep the VM on and nothing ever happens to it. With a reservation, you have more flexibility, but you also have a little bit more of a user impact. Okay, let's see how it actually works on the back end. So I mentioned this in the previous session, but let's look at the screens here. So there's something called automation account. So there's something called Azure Automation, which is a PaaS product. You write what's called a runbook, which is kind of like a PowerShell script. And then you submit it to an automation account. You provide the account the necessary credentials to run that particular runbook or a script. And then you give it a schedule on which it's going to run. So when someone enables Autoscale in the Nerdio admin portal, an automation account gets created called Nerdio Automation. And then if you go into this automation, you can see what runbooks there are. There's one called Autoscale. It's a PowerShell runbook. It was in this particular account created on the 16th. If you click on it, you can see the last time it ran. You can see the schedule which it runs on. So it runs hourly at basically 45 minutes after the hour, and it just runs every hour of every day. And then you can also see the jobs that it actually performs. So you can see every hour this runbook runs, starts at 15 minutes to 11. And in this case, it took it 53 seconds to run. In some cases, it takes it 10 minutes to run. And I'll explain why that varies in a minute. So you can see it basically just runs every hour. It looks at the VMs, makes a determination about what to do with them, and then executes any actions that may be necessary. Okay, so it gets executed every hour. Now let's see what it actually does. So when this automation runbook executes, it gets a list of all of the VMs, which is something like this, right? So this is a list of all of my VMs. It then pulls a list of tags off of a particular VM. So for instance, here's a VM called PRXL1, and it has these tags. It looks at whether Autoscale is enabled or disabled. And if its Autoscale is disabled, then it is going to evaluate the rest of the tags. If Autoscale is, sorry, if it's enabled, it's going to look at the tags. If it's disabled, it's going to basically ignore the rest of the tags. But let's assume for this particular VM, this Autoscale is enabled, and then it has a schedule for every day of the week. And every day of the week has 2 transition points. Okay, one, at start of the day and end of the day kind of a thing. So the easiest way to think about it, if you have work hours of Monday through Friday, 6 a.m. to 6 p.m., then the Monday Autoscale command is going to say 6 a.m., whatever, Central Time, make the VM be of a certain size, and then 6 p.m. either turn it off or make it be a different size. And that's kind of what's encoded in here. This first number is the hour in UTC. So this 3 a.m. equals whatever it is, in Central via UTC. And then what comes after the colon is the size of the VM that should be set at that time. And then this is the end of the day. So you can see this is 12 hours later. So from 3 a.m. UTC to 1500 hours UTC, then the VM gets resized to this size. Now it happens to be that it's the same size, so nothing is going to happen. But you can have different options here. You can have something happening in the morning and something different happening at night. You can have something turning on in the morning, turning off at night, turning off in the morning, turning on at night. So you get the idea. You basically encode the schedule into these tags, and then the runbook automation will go through these tags and decide what to do with the VM, and then execute the instructions based on these tags. Now, there are 3 types of auto-scaling. We talked about 2 of them in the past, but let's summarize them again. There is the simplest one to understand is auto-scaling of server VMs. So in the NAP, this is accessed through the servers module manage servers section, and each server has a little icon next to it to tell you that auto-scale is enabled for that server. The way you enable it or modify the schedule is by selecting Autoscale from the Actions menu here. You define the work hours, which kind of gives you that 2 transition points for every day, one in the morning, typically one at night. The time zone, which is then converted into UTC when the schedule is submitted. And then, sorry guys, looks like a question. Okay, I'll get to it in a minute. And then the actions, right? So basically there is the VM size, which is what it should be during business hours. And then there is an action that happens outside of those business hours. So either power it off, no change, or set it to some other size that is supported. Okay, so that's what happens with server VMs. Once I make these changes and click confirm, there's going to be a background task that's going to run, and this background task will basically submit the Autoscale schedule. You can see that it is a background task. There's no username associated with it. That background task will go through all of the VMs and actually rewrite all of these tags based on what the NAP thinks they should be. Very good. So now that was the first type of autoscale. The second type of autoscale is the RDS collections that we already looked at a number of times. So if you recall with RDS collections, we still call it autoscale, but it actually works in a completely different way. It has nothing to do with an automation runbook. It has nothing to do with tags. It has everything to do with a VM scale set, which has triggers for CPU utilization, and it grows the scale set or shrinks the scale set. It does not resize the individual VMs. So just for terminology clarification's sake, autoscale applies to anything that, resizes the overall compute to fit better to what the consumption is. There's two ways to autoscale. You can either scale up and down. Scaling up and down means increasing the capacity, like the CPU and the RAM, of a particular VM. Scaling down means decreasing it. So going from, let's say, a B2S, which is 2-core, 4 gigs of RAM, to a B4S, which would be a 4-core, 8 gigs of RAM, would be a scale up operation. And then going from a B2S to a B1S would be a scale down operation. The server VM autoscale uses that methodology. It uses scale up and scale down. Scale up and scale down because it acts on a particular VM object is disruptive, meaning it shuts down the VM, makes the change, and then turns it back on. So anyone who's on that VM at that time will obviously not be able to access it during that operation. Scale out and in is a horizontal scaling mechanism, which means that instead of messing with any one particular VM, when you scale out a VM scale set, you're adding a VM into the mix, making it available to support additional load. And that's how RDS collections work. So when it scales out, it adds a VM. When it scales in, it removes a VM. There's no scaling up and down. That means that on a scale out operation, it's not disruptive because it's not affecting any of the existing users who are connected to any existing VMs. On a scale in operation, when it's removing a VM, it may or may not be disruptive. It may be disruptive if there are users on that particular VM at the time when it scales in, and it will be non-disruptive if there are no users on that VM and all the users happen to be on the other VMs in that same scale set. Okay, so from a terminology standpoint, scale in and out is for scale sets and RDS collections. Scale up and down is for server autoscale and is disruptive. Okay, the third type of autoscale applies to users who are using desktops that are not in an RDS collection. So remember, RDS collections are optional. They're not there by default. It's something that the user has to add and make available to the end users. By default, you get RDS session hosts and assign users to individual VMs, or you get VDI desktops that each user gets, right? So for those scenarios, how do you autoscale that compute capacity? What you'll notice is that for RDS session hosts, there's not an autoscale selector here, whereas there is for every other VM. And the reason is because there's a whole separate mechanism for autoscaling RDS session hosts and VDI machines. And that is found under the Optimize menu under Desktop Autoscale. So the Desktop Autoscale works in the following way. There are 3 work hour profiles that you can customize. You can customize them in the sense that you can change the schedule, but you cannot change the name. The name is sort of fixed. So let's look at them. So there's workaholic productivity and work-life balance. And the prerequisite here is they have to be nested within each other, meaning, by default, workaholic is a work hour profile for someone who works 24/7. Productivity is nested within that 24/7, obviously, because 24/7 is every hour of every day. This is 12 hours of those 7 days. And then work-life balance is yet again nested within productivity for users who are only working 10 hours out of those 12 hours and 5 days out of these 7 days. So if you try to create a schedule where some of these are not nested, it's going to give you an error because it doesn't really make sense for autoscaling to work, as you'll see in a minute, if they're not nested within each other. Okay, here are the settings. In the work hour profiles, you have the name, you have your schedule. Okay, so actually let's modify a different one. Let's modify the productivity one. Okay, so you have your name, you have your work days, right? So Monday through Sunday, Monday through Saturday, Monday through Friday, weekend only, 3-day weekend, 2-day weekend, a few different selections. Then you have your work hours. That's pretty self-explanatory. You have a description of what it is. You have a time zone, right? The time zone makes a big difference because, you can say 7 to 7 Monday through Friday, but it may mean something different, and it obviously means something different to different time zones. And then this section is where you actually add users to this particular profile. So what you're telling the system by selecting users is you're saying that these users are expected to work these hours. Now, it doesn't matter if the users are VDI or RDS. What you will not see in this list are users who are on a collection, because this does not apply to collections. Collections don't scale up and down, that scale in and out. So these are only users who are on a VDI or an RDS session host. Okay, so you add these users and you click Save. And again, you can do that for all three profiles. A single user can exist in only one profile because you're basically setting that user's work hours in order for the system to determine the optimal sizing of that user's VM. Now, once you do this grouping, then the system needs to figure out, okay, well, what do I do with that, right? So you told me you have this group of users that's expected to work these hours, and that group of users that's expected to work that hours. What does that do in terms of translating it into an action? So let's start by thinking about how that works for VDI desktops, because it's easy to understand. Each user is dedicated to a single desktop. It's a one-to-one relationship. So if a user is in a workaholic profile expected to work 24/7, that means that their desktop will never be affected by Autoscale, because there isn't ever a point when the system knows the user is not expected to be working. On the other hand, if a user that's a VDI user is in a productivity profile, that means that outside of these hours, the user is not expected to be on the system, and therefore the system will simply be shut down during non-work hours and automatically started at the beginning of work hours. Now with RDS, things get more complicated, because you can have a single RDS session host that has, let's say, 100 users on it, and a portion of those users maybe are working 24/7, portion of those users may be working 9/5, whatever the case is, there could be a mix and match of that situation. So what the system does is it lists down here what it called the action plan. So any workstations that are VDIs are simply going to be stopped after work hours and started before work hours. Any session hosts get what's called an action plan. So let's look at an action plan. And the action plan is a schedule that gets created and is submitted to Azure in form of tags, just like you saw for server Autoscale, because ultimately that's what it is. It's taking a set of tags and it's submitting them to Azure on a particular virtual machine. In this case, RDSH01 is the machine that is going to be submitting it to. And the way it determines what those tags are is by mapping out the 7 days of the week and mapping out 24 hours of each day, and basically presenting the user with what's expected of that system during that time. So let's look at it visually. So you have number of users on RDSH01 on Mondays. Okay, so this is Monday's schedule. And the way we've configured the system is it knows that it's got 2 users during all the hours. So you can see this is the workaholic profile. So 2 users during all the hours. And then there's going to be 1 additional user on top of these 2 users during work hours from 8 to 6. Okay, and the way you configure your profiles is what this graph would reflect. And then you can see there are 2 transition points. One happens in the morning, one happens in the afternoon. And the system will resize itself automatically in the morning to accommodate these number of users, so 3 in this case, and then it will size itself down to accommodate these users, which is 2. Now, there's really not a difference in terms of 2 and 3, so nothing will happen in this particular case, but you can envision a situation where you have 100 users on a particular host, and then during off hours, there may be 5 users on the system, and during regular hours, they're all 100. So there's definitely going to be a resize action. And if you click on this transition point, you'll see a screen that looks familiar. There's additional option here that says automated, let NAB decide. And the way NAB decides is by looking at the baseline size. So if the baseline size, again, this is a demo count, so it's not, not the real world situation, but if the baseline size, let's say 16 cores, and the number of users during work hours is, let's say, 100, and then during off hours, the number of users is 25, just to make the math easy, the NAP will decide that it needs to take a VM that has 16 cores as its baseline and reduce it down to a VM that has 4 cores to accommodate a quarter of the total user population. Okay? That's automated. You can also say no change. You can say change it back to my baseline. You can say power off. So there's a few manual overrides, or you can actually have it be resized the way you see fit. So by default, when you set up desktop autoscale for RDS session host, it's going to create this transition points with automatic let NAB decide. And then again, you'll see every day there are 2 transition points. You can go in and manually override these. Now, remember, we have this work-life balance that adds an additional user, and that's only 8 a.m. to 6 p.m. Monday through Friday. So if we go to Saturday and Sunday, what we expect to see is that there's only these 2 users who are in the workaholic profile, and there aren't any work-life balance users, and therefore there's no transition point because the number of users is not expected to change throughout the day. Okay, so you can make your changes and click save. Again, by clicking save, you'll have a background task that will submit the tags, which is the schedule, to Azure, and then the automation script will pick those up after hours. Oh, I'm sorry, within the next time it runs, which is going to be 15 minutes before the hour, and evaluate them.